Here we go. So in this one, we are factoring quadratic expressions again, but specifically when a is greater than 1. When we talk about a being greater than 1, we're looking at that quadratic term. So we have ax squared plus bx plus c. And we're thinking about this coefficient here. The reason I'm specifically looking at this type is because this is when quadratics tend to get confusing for students. And it's because if I look at this expression, there's no GCF at all. So nothing would divide into 5, 49, and 36. So there's no way that we would have a GCF. But when we think about how did we get this quadratic expression, this does factor like all the others, but we want to think about this beginning quadratic term. So r squared would have been coming from r times r. We know that. But we don't have an r squared alone. We have a 5r squared. So the way that we could multiply to get a 5r squared is if we had 5r times 1r. This makes the guess and check method a little bit trickier, but it's still more intuitive than some of the other methods that are out there. So when we think about undoing this, we have the quadratic term that we have factored, and then we skip to the 36. So we think again, what times what gives me 36? Well, this makes the guess and check method have a few different options. So I'm going to try 6 and 6. If I check these answers by distributing, I know that 6 and 6 does not combine to give me 49, but I'm not worried about that because 6r comes from the middle section, but 5 times 6 is 30r, and combined together that gives me a 36r. Still not what we're looking for, but it gets me a little bit closer. Alright, so let's change that from a 6 times 6 to something else. There are some other ways to get a 36. So if we listed out some of these ways, I know that 6 and 6 is one of them, 12 times 3 is 1, 9 times 4, 2, and 18 if you want to keep going. But I'm going to jump to the 9 times 4 option. So 9 and 4. 9 times 4, or r is 9r. 4 times 5 is 20r. That does not combine to give me the one that I want. However, I can swap these. So this time the order matters, because if I put the 4 here and the 9 there, it makes a completely different quadratic expression. Because on the middle I have 4r, and on the outside 9 times 5 is 45, so I have 45r. This can combine if I have a negative 4 and negative 45 to give me negative 49r. So I do want negative 4 and negative 9. That combined to give me that negative 49r. It multiplies to give me a positive 36 because I have a negative times a negative. So my actual finished answer is the 5r minus 4 and the r minus 9. The order matters as far as the numbers, but the factors you could write in a different order. So you could have written this as r minus 9 first times the 5r minus 4. Alright, so let's jump to number 2. Again, the first rule of factoring will always be look for a GCF. So if I look for a GCF here, 7, 53, 28, 7 can go into 28, but it can't go into 53. So 7's not a GCF, but if you notice that all of them have an n, then n is a GCF. So we're factoring out that n from each term just like we did in the GCF video. And we're going to continue factoring this quadratic expression. So the 7n squared minus 53n plus 28 is a quadratic expression. I think about how did we get a 7n squared? What times what would give you a 7n squared? Well, to get a 7, it'd just be 7 times 1. To get an n squared, it'd be n times n. So we need 7n times n to give me a 7n squared. Then we jump to the 28. So 7 and 4 gives me a 28. We could also do 14 and 2. Or you could do 28 and 1. One of the things that helps as you get really used to factoring and looking for GCFs, I can try 7 and 4, although I know that it's already not going to work. Let's just show and then I'll tell you why. So 7n would be in the middle. 7 times 4 is 28n. So if I combine those, we only get 35 and we need 53. But here's why it doesn't work, or I knew it wasn't going to work already. And whoops, let me give that back to you. And that's because when I look here at that first factor, 7n and 7, that implies that there would have been a GCF of 7 that you could have brought out. We know there's no other GCF than n because we already looked for what the greatest common factor was. So I didn't really need to try the 7 and 4 there in that placement. So I should have just went ahead and tried it with the 4 here and the 7 on the outside there. Now when you try this, 4n is in the middle, and 7 times 7 is 49n. And this does give you a 53. Now we need a negative 53, so negative 4 and negative 49 is negative 53n. That would make this negative 4 and negative 7, which does multiply to give you a positive 28, which is what we wanted anyway. So our final factored form is just n 7n minus 4, n minus 7. That's why we always look for a GCF first, because it's going to make your factoring easier. Alright, and if I go to 3, 7n squared, 69n, 54, there's not a GCF at all. So it's not guaranteed that you're going to have a GCF, but it is always important to look for one first. So we look for a GCF. There's not one in this case. And I would just jump into my regular factoring. Alright, so if I factored this 7n squared again, it came from 7n times n. And then we're looking at, well, what are the ways we could get a 54? You don't have to necessarily write these out every single time. You know, 9 times 6 is 54. You could have a bunch of different options that you try out. Alright, as you get better with your multiplication and just kind of checking this stuff out with these binomials, it'll be easier, but I'm going to jump to 9 and 6 and try it out here. Guess and check. On the inside we have 9n. On the outside we have 42n. That combines to give me 51, so that's not going to give me the 69 that we need. A common mistake is just giving up on 9 and 6 because we tried it, but we didn't try a different order. So putting the 6 here and the 9 there is different because now the 9 is what's multiplying to the 7. So we do get a 6 in here, and 9 times 7 is 63. 6n and 63n is 69n. So that is a positive and a positive that we need. This would just factor again into 7n plus 6 times n plus 9. Alright, and so here in number 4, I've given one that looks a lot bigger because it has an a to the 4th power, but it's still a trinomial. Remember, trinomial means that there are 3 terms, and we have 3 terms here separated out with the subtraction signs. Alright, if I look for a GCF, 3 cannot go into everything, but they do all have an a in common. And we want the greatest common factor, so the biggest or the most amount of a's that we could take out of each term is an a squared. So that would leave me with a 3a squared minus 7, sorry, not 7, minus 14a minus 49. That a squared is a factor. It's the greatest common factor, but it is going to hang out front while we try to continue factoring this quadratic expression. I'm looking at 3a squared. What things multiplied to give you a 3a squared? It would be 3a times a. Then we jump to the 49. Not sure what gives us a 49 other than 7 times 7, really. So we're going to try a 7 and 7. If you don't check your insides and outsides, you often make mistakes, especially when it comes to signs. I know I'm supposed to get a negative 14, but if I had negative and negative, that would multiply to give me a positive 49. So that's one thing to just kind of make sure we pay attention to. On the inside, we get a 7a. On the outside, we get 21a. That can combine to give me the negative 14 if that was negative 21 and a positive 7. So we actually want 3a plus 7 and a minus 7 because we needed the negative 23 or 21 here. So that's our factored form. A squared times 3a plus 7 times a minus 7. Oops. There we go. Oftentimes the guess and check method gets a little bit messy here, so I always recommend you do it in pencil, but just know that it is going to get easier as you guess and check and get used to the method. Alright, so here are 4 for you to try. I'd pause the video and then you can jump back in and see if you got the answers correct. Alright, so if you already factored these, there was no GCF in the first one. We need, let's see, the only way to get a 45, 9 times 5. So let's put our 9 there, 5 there. We need negative 9 and positive 5. So 2x plus 5, x minus 9. So for number 6, the first thing you would do is look for your GCF, which would be 6. You're left with 3v squared plus 16v plus 16. To get a 16, you could multiply 4 times 4. It would give you 12v in the outside plus 4v, which is 16v. So there's our factored form, 6 times 3v plus 4 times v plus 4. In number 7, there's no GCF at all. So we just have 5n times n. Then to get a 6, you could do 3 and 2. I would need 2 here and the 3 there to give me negative and positive. 8, there is no GCF again. So 3v times v. Things that multiply to give you 72. There's a bunch of different options. I need the 9 here and the 8 there. So negative 9, negative 8, this would multiply on the outside to give you negative 27, on the inside negative 8, which does combine to give you negative 35. And it would have multiplied negative 8 times negative 9 to give me a positive 72. Alright, again, there are 2 more for you to try, so if you want to pause the video one more time. And if you've already tried these, that's fine, but if you want to just work them with me, we'll go ahead and check our answers. So in number 9, the first thing I noticed is that negative. That tells me I want to pull out a negative as well. So it doesn't matter if that was the only GCF, I'd bring out the negative. As I look at 4, 26, and 36, actually everything's divisible by a 2. So that leaves me with a 2a squared, a positive 13a, and a positive 18. That negative 2 is going to hang out front as the GCF. And then we jump into how did we factor 2a squared? So 2a times a. Factors of 18. You can do 6 and 3. Oops, 6 and 3 doesn't work. 9 and 2. 9 and 2. So on the outside we'd have a 4a. On the inside is 9a, 9 and 4 is 13, so that's what we need. 2a plus 9 and the a plus 2 with a GCF of negative 2 out front. And lastly, number 10, there is a GCF of k in common with all of them. So 7k minus 50k plus 48. Seven k times k, is the 7k squared. But there are a lot of things that multiplied to give you a 48. So you could try 12 and 4. You could try 2 and 24. You could try 8 and 6. 16 and 3. Alright, and 8 and 6 does work if this is the 8. And that's the 6. Actually, sorry, that does not work. Here's why this is common to do. That would be negative 56. So let's say I try that. 6k and negative 56k. That gives me the negative 50. However, 6 and negative 8 is a negative 48. So that's actually not what we want at all. Alright, so we need something different other than 6 and 8 that way. Let's try it with the 6 here and the 8 there. On the inside, that gives me 8k. On the outside, 6 times 7 is 42k. That's what we need. We need that to be 50. Because I need a positive and a positive to give me that. Oh, sorry. I don't need a positive and positive. We need a negative and negative. See, we all make mistakes. Alright, but that's quick and easy to fix. This is why we look at the signs at the very end as well, just to kind of double check we're doing what we need. Alright, so there's more practice that I've posted on this, but this is incredibly important for pre-cal.